Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so in this video we are almost at the end of the lecture 5 of the final part of chapter 1 integration, lecture 5 of 5 with 1.4 definite integrals. Okay, so definite integrals help us to find out for definite integrals, it's also help us to find the area between the curve and also x-axis, and also right now we are going to look at how these definite integrals to find out the volume when you rotate the 360 through x-axis and also y-axis. So then at the end of this topic, students should be able to determine the volume of a solid revolution. Just imagine that this is the so this is the graph of the area, okay, the area between the curve of y equal to fx with x-axis and also x equal to a until x equal to b. Okay, so this is the area now. So just imagine that if this area rotated 360 degrees to the x-axis, okay, it becomes something like this. So then this curve, okay, this area rotated 360 degrees to the x-axis, it gives us something we call a picture of 3D, something like a vase or maybe a drum, okay. So in this case, when the area rotated 360 degrees revolving a region 360 degrees about the x-axis. And the formula of the volume equal to pi is a mass, integral of y squared dx. So y equal to fx here. So just imagine that if f y equal to x squared, for example, so then volume equal to pi integral of y, which is x squared dx. Okay, this is not x squared, for according to this picture is not x squared, but just imagine that to make you all understood y here, according to the y equal to the function of f with a variable of x respect to the x here. Okay. And also volume of a solid revolution revolving a region 360 degrees about the y-axis. So just imagine that this is the area. Okay. And then this area rotated 360 degrees to the y-axis. And if you look at this part here, okay, is you can name it any, something we call any shape of this one. It might be like a drum, or maybe I can name it what kind of shape that we can see here. But you just imagine that if this, we call this area rotated 360 degrees, then we get is a 3D or pictures of your dimension with a height, shape, and all that. And volume equal to pi integral of x squared dy. Okay. Okay, so now example 1. Find the volume of solid generated by revolving the region bounded by the curve of y equal to x squared plus 1. X-axis. The line of x equal to 1 and x equal to 2 through 360 degrees about the x-axis. Okay, now okay. Okay, now here. y-axis, and then y equal to x squared plus 1. X squared plus 1, curve something like this. Okay, y equal to x squared plus 1. and, and the length of x equal to 1 here, x equal to 1 until x equal to 2 here. So this is the area. Right now, we're talking about the volume. So just imagine that if this core rotated 360 degree to the x-axis, okay, and also this one here, it gives us something like this one here. Okay, this is an x-axis, and this is a part of it. Okay, and also we got this one here. It rotated 360 degree to the x-axis. So it's a 3D pictures here right now. So then v equal to pi integral of x squared plus 1 square respect to the x, okay, to the x-axis dx from x equal to 1 until x equal to 2. Now pi, we need to expand this first, okay, we need to expand this first, come out with x to the power 4 plus 2x squared plus 1 dx from 1 until 2, then pi integrate this respect to the x 1 by 1. Here come out with x5 divided by 5 plus 2x cubed divided by 3 plus with an x from 1 until 2. Okay, now it's time for us to substitute the value of x equal to 2 and x equal to 1. Pi, okay, we substitute x equal to 2 first. So 2 power of 5, 2, 4, 16, 32 and 64. 64 divided by 5 plus 2, x equal to 2, 2 cubed equal to 8 times 2 equal to 16 divided by 3 plus with 2. Minus and substitute all the x's here with 1. 1 over 5 plus 1 cubed times 2 equal to 2 over 3 plus with 1. Okay, now it is equal to, okay, you may use your calculator and try to get it answers here, which is 178 divided by 15 pi unit cube. Okay, so the rest of it you may just, okay, you may calculate manually or use your calculator until you get it. We call the answers of this 178 divided by 15 pi unit cube. Okay, next question. Find the volume of the solid generated by revolving region bounded by the curve of y equal to x cubed. Then y-axis, y equal to 1 and y equal to 8 through 360 degree about the y-axis. Okay, now let's sketch the graph of y equal to x cubed. Okay. So this is the graph of y equal to x cubed. Then now, okay, region bounded by the curve y equal to x cubed. So this is the graph, y equal to x cubed. Y-axis, y equal to 1 until y equal to 8. Okay. So this is the area that we're going to rotate 360 degrees to the y-axis. Okay. So just imagine that there is also another side of this one here, and it looks like a bowl. Okay, it looks like a bowl with 3D shape here. So now we are going to find the volume of this. V equal to pi integral from 1 until 8 dy. Through 360 degrees about the y-axis, so we rotate it to the y-axis here. What we have here right now is y equal to x cubed. And we're going to form the function into the term or function of x equal to fy. Okay, how is it possible we can change this one here? Is it possible for us to change y equal to fx or x cubed into x equal to the function of fy? Okay, now y equal to x cubed multiplied with 1 over 3 here, left and right. So 3 times 1 over 3 here, then x equal to y to the power of 1 over 3. So then here now, x here is y to the power of 1 over 3. Okay, then we don't forget that we call square here. Okay, then now pi integral from 1 until 8, and this one here 1 over 3 times 2, it is y to the power of 2 over 3 dy. Integrate this. Okay, y power of 2 over 3 plus 1, or 2 over 3 plus 3 over 3, come out with y power of 5 over 3, divide by 5 over 3, or bring the position upside down here, come out with 3 over 5. From 1 until 8. And now, 3 over 5, substitute y with 8 first, which is 8 power of 5 over 3, and minus 3 over 5, then y equal to 1 to the power of 5 over 3. Okay, now pi cube root of 8. Cube root of 8. So in this case here, cube root of 8, which is equal to 2. So then 2 power of 5 is 2, 4, 6. 2 times 3, 4, 8, 16, and 32. So then 3 over 5 times 32 minus 1 for 3 is still 1 here, minus 3 over 5. Okay, 3 times 2 equal to 6. 3 times 3 equal to 9. 96 minus 3, it is 93 over 5 pi unit cube. There you go. So let's take a look at the next page. Okay. So a volume of solid generated by revolving a region bounded by the two curves of y equal to fx and y equal to gx. So look at this one here now. To find the area of this, we need to find the intersection point between this and this. Okay. And previous knowledge of to find the area between these two curves here, we come up with A equal to integral of, okay, this graph is above the gx. So then fx minus gx dx. But before that, before we substitute with value of x, from A to B, we need to find out the intersection point here by coming up with fx equal to gx until we get x1 equal to A and x2 equal to B. Okay. So then, to find the volume, there's still here pi integral of, okay, to be careful here, is fx squared minus gx squared. Okay, sometimes students come up with this, from A until B, fx minus gx squared dx, which is totally wrong. So please be careful that the square, okay, for the function 1 by 1. Okay, and also here, whether we call revolving by the two curve of y equal to fx about the y-axis. Okay, it rotated to the x-axis here. And this is it. And this is it, the volume. I'll put the formula of the volume here. The region bounded by the curve y equal to square root of x and y equal to x cubed. Find the volume associated by revolving through the x-axis and y-axis. Okay. Y x. Okay, so this one, y equal to square root of x. I sketch with a, we call color of the blue ink here, and then y equal to x cubed. There you go. This is y equal to x cubed, and the blue ink color graph here represent y equal to square root of x. So there is an area between these two curves, the blue curve and the purple curve here. There's an area bounded by these two. Okay, just imagine that this area rotated 360 degrees to the x-axis or might be to the y-axis. So if I sketch through the y-axis here, it's just something like this. Okay, rotated 360 degrees to the y-axis. Okay. And so on. You may try, okay, sketch the graph of the, we call the shadow of this on the y-axis here below here, and then rotated 360 degrees to the x-axis. Okay, so now V1 means that the volume rotated to the x-axis here equal to pi integral of which graph? The graph y equal to square root of x is above. So square root of x square minus, and the graph below here which is y equal to x cubed square dx. Okay, pi from, okay, now we need to find the intersection of this. In this case, okay, which I think that we discussed this in our previous lecture of the, to find the area. which is y1 equal to y2 square root of x equal to x cubed. So to terminate this square root of sign here, come up with square left and right. So then x equal to x power of 6. So then x6 minus x equal to 0. Then x minus power of 5 minus 1 equal to 0. Then x equal to 1 and x equal to 0. 1 here. Okay, so then now pi between this and this, from 0 until 1. From 0 until 1, terminate between this square root sign and square, come up with an x here, and then this one, x to the power of 6 dx. Pi, and integrate x squared divided by 2 minus x 7 divided by 7 from 0 until 1. So then here pi, substitute 1 here, 1 over 2, 1 squared is 1 over 2, minus 1 power of 7, still 1 over 7, and minus 0 and 0, everything 0. Okay, so then here now, what can you see here now? It is pi 1 over 2 minus 1 over 7, make it 1 over 14. 2 times 7 and 1 times 7, 7 minus 2, which is equal to 5 over 14 pi unit cube. Okay, I think that I'm going to clear this off. And volume 2, which is pi integral of, okay, now again here, what about this one here? X equal to 1. So when x equal to 1, 1 cube equal to 1. Okay, we have found the intersection point between these two curves and found that x equal to 1. Substitute x1 into this one, into this function equation here. 1. 1 cube also equal to 1, means that y also equal to 1. Okay, look at this graph now. To the y-axis. To the y-axis, the graph in purple in color here is above and the blue is below to the y-axis. So then, in this case, come up with x cubed squared minus square root of x squared dy. Okay, respect to the y, which I think that we need to make some adjustment here. Okay, it's not it. Okay, sorry. V equal to pi integral of y equal to square root of x. Change this into the form of x equal to the function of y. So x, if I square here, then also square here, x equal to y squared. Am I right? Y equal to square root of x. So the square left and right. There you go, x equal to y squared. And then what about this one here now? Y equal to x cubed times 1 over 3 here and 1 over 3. Then x equal to y to the power of 1 over 3. So this curve of y equal to x cubed, in the function in the form of x equal to fy, it is y over 3 here, because this curve above this to the y-axis. Okay, so it is y power of 1 over 3 square minus, and this one here now, it is y square dy. Okay, then by integral this from 0 until 1, and here now y 1 over 3 times 2 over 3 minus y power of 4 dy. Okay, pi. Then integral of y of 2 over 3, so 2 over 3 plus 1, or 2 over 3 plus 3 over 3, which is 5 over 3 divided by 5 over 3, or switch the position upside down, it becomes 3 over 5. And minus integral of y power 4 dy, y power 5 divided by 5, from 0 until 1. Okay, as usual, we substitute the value of y 1 first. Okay, 1 and 0, which I think that is all easy. Y power of whatever equal to 1. 1 power of 5 over 3 is still 1, so 3 over 5 minus y 1 power of 5 is still 1 over 5 minus 0 and 0. So then 5, and here 3 minus 1 of 5 and 5, 3 minus 1, which is 2 over 5 pi unit cube. Okay, so 2 over 5 pi unit cube. Okay, so this is it. We call when the area between the curve x-axis x equal to a and b, we rotated 360 degree to the x-axis. It's just like we got something like that one here. Okay, we rotated 360 degree to the x-axis. It gives us something we call looks like a vase, or might be a glass. Okay, and also revolve this, we call this curve revolve to the 60 axis, and this is the formula. And for both of this graph, the area bounded by the two curves to the x-axis and to the y-axis. Okay, so I have a recall exercise for all of you. And this exercise, to find the find the volume of the solid generated here. The final answer. The final answer for this, volume equal to 2 pi plus 3 over 4 pi square unit cube. Okay, try by yourself, and hopefully that you can make out the result. It helps you to continue with the rest of your tutorial and past year questions. That's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.